severe accident in a nuclear reactor involves significant degradation of the core geometry and may include releases of large amounts of radiation to the environment. It's important that we understand the phenomena and mechanisms involved in severe accidents for several reasons, including designing safer reactors, improving regulation, and planning for emergencies, how we would evacuate people, for example. The question is, though, how do we learn about severe accidents in a way that will be instructive? Well, one way to do it is to instrument an operating reactor, turn off all the safety systems, and melt it down. Fortunately, though, we have some better options. One would be to do some calculations of the full core, but it's also necessary often to do experiments. If we're going to do experiments, we need to make them smaller, more economical, and safer, though. So we may use replacement materials, we may use lower temperatures. There are various changes that we can make. The question then becomes, how do we extrapolate from the results of the experiment to what we would expect in an actual accident? So this process of extrapolation is something we refer to as scaling. An example of scaling would be if you wanted to know the mass of a sphere. You may be able to conveniently measure the mass of a small sphere. You take it, you put it on a scale, you learn the mass, and you can also measure the diameter of it. The question then is, how do you extrapolate to a much larger sphere? So it may be the case that you don't have a scale that can measure the mass of a larger sphere, but you can measure its diameter. So what you do is you have a mathematical relationship that allows you to extrapolate from the mass of the smaller sphere. And you determine that it's, say, 10 times the diameter, and from that you can learn that it's 1,000 times the mass of the smaller sphere, so long as it's composed of the same material. So a similar thing can be done with severe accident phenomena. The relationships are much more complicated, potentially, but we can set up a system where we list all of the phenomena and we have a way of extrapolating each of them to different scales. It's important that we do this for all of the phenomena involved in severe accidents, and there are some holes in our knowledge of these scaling relationships, and in addition, we've never pulled together all of the scaling relationships that we have for particularly severe accidents in CANDU reactors. So I would propose that we do this for CANDU reactors and severe accidents in general in a very comprehensive way. This would allow us to help with our understanding of severe accidents, and management planning would also help us with planning our R&D. And even further, it would help us with our assessment for novel reactor types, for example, Generation 4 reactors or small modular reactors, where we have not put as much effort into severe accident analysis because we haven't built them yet. But in terms of planning which ones we want to build and assessing what the risks are with a fairly small amount of effort at the early stage, we could do that using a similar scaling approach. Thank you.